Hey everyone, you know how when you are just randomly walking, you have speed, but the moment you move in a fixed direction, that becomes velocity. So, why does that matter? In this video, I am going to explain what is speed and velocity, their definition, properties, units, and formulas, and some cool graph related to velocity. So, let's begin. So, before going to definition, I want to explain you something that when any object moves, it covers a certain distance, right? Like if an object moves from point A to point B, it covers a certain distance. So speed is distance covered by a body in any direction per unit time. It takes time. When the body covers any distance, it takes time. So our speed is the distance covered by any body per unit time in any direction. Why I told in any direction? Because there is a brother of speed. Yes, I am not kidding. There is a brother of speed which is called velocity. Velocity is speed, but in particular direction. So the definition becomes velocity is a distance covered by a body in a fixed direction per unit time. Now you know why I have told in any direction and in fixed direction, because there are two terms, speed and velocity. Speed is a distance covered by a body in any direction. When a person tells you this object has covered a speed, so you have to remember that the object the person is telling is not in a fixed direction. But if a person tells that the object is moving in the velocity, so you have to know that the object is moving in a fixed direction. So the definition: speed is a distance covered by any body in any direction per unit time, and velocity is the distance covered by any body in a particular direction. So let me talk about properties. Okay, so properties, yes, properties. Does speed and velocity even have properties? Yes, it already has involved in the definition. It has already came in definition, but there are one properties of each speed and velocity. They are, as I have already told you, speed is the distance covered by any body in a fixed in any direction. So that property is called scalar quantity. So speed is a scalar quantity. So what about velocity? So velocity also has a property which is called vector quantity. Velocity is called vector quantity because it has both magnitude. In this term, magnitude means time. Okay, speed has time. Yes, speed has time, but no any fixed direction. But velocity has time and both and direction as well. So velocity is called vector quantity. Now, so what about unit? Unit, yes, as we know, any quantity. Yes, I have already mentioned that speed and velocity is a quantity. One is scalar and one is vector quantity. So what about unit? And we know every quantity in this universe has a unit. Like weight is a quantity and it has unit Newton. So both speed and velocity is a quantity which has unit. Okay, so what's that? From the definition of speed and velocity, I have told the definition of speed and velocity, which is a little bit common, which involves the distance covered by anybody in a fixed covered by anybody in a particular period of time. So this that part of definition is same. The only difference is one can be in any direction and one must be in fixed direction. So little bit of the definition are same, right? What is same? That the part in which the definition tells that the speed and velocity are both distance covered by any body in a period of time, which means, whoa. I have told that both in both definition the distance covered by any body in per unit time is both the speed and velocity. But why I have written distance upon time in speed but velocity displacement upon time in velocity? Because distance can be in any path, okay, like the distance from Bhutol to Pokhara, or the distance from Nepal to India can be in any direction, okay, like okay, let me do this. So this is one point and this is another point, okay. So to get from here to here there is any path, okay, we can go like this, like this, like this, like the long way, but okay, and that's distance can be in any path, but the displacement, yes, displacement is the shortest one, okay, like this. In this scenario, from point A to from point B, this is the shortest path, which is displacement. So we get the another definition of displacement, which is the shortest path from point A to point B, or the shortest path from one point to another point is also known as displacement. So that's the reason why we take displacement in velocity and distance in speed, okay. So all right, now for the exciting part, velocity time graph. Yes, we are going to use graph for the next topic. So in the starting of the video I have told we are doing something with graph, okay. So our next topic is velocity time graph. And what's that? So that's basically, well, okay, well, you have done some numericals, right? So like where this much velocity, this much time, so take out the acceleration, and so when you plot those things in graph, okay, or it can be defined as the geometrical relationship or the graph which represent the geometrical relationship between velocity of a moving body and the time taken of a moving body. That's it. So if a graph represents the relationship between the velocity of a moving body and the time taken of a moving body, the graph is said to be velocity time graph. So there are four main types of velocity time graph. What are they? The first one is straight line. Okay, this might seem a little bit of congested, but I will try to explain my best, okay. So in bottom down I have written time, okay. So 2 seconds, 4 seconds, 6 seconds and 8 seconds, and we can see our body is in 10 meter per second, okay. The one unit equals 5 meter per second, so 5, 10, 15, 20 and 25 meter per second. And in this graph we can see our body, okay, our body, this is the starting point of our the starting point of our body, and this is the ending point of our body. So our body is in 10 meter per second, okay. The velocity is 10 meter per second in 2 seconds, okay. The time taken, okay, so in equal to from jumping to 2 seconds to 4 seconds, the velocity is still 10 meter per second. From jumping 4 seconds to 6 seconds, the velocity is still 10 meter per second, and from jumping 6 seconds to 8 seconds, the velocity is still 10 meter per second. So the following graph is constant, okay, no increase neither decrease in velocity. So the following graph becomes uniform velocity. What? But how? Because uniform velocity is the velocity when the body is in a constant speed respect to time. So in this graph, the body's velocity is constant, right? It is constant, okay. 10 meter per second, it is constant from 2 second to 8 second. So which means the body gets acceleration 10 meter per second in 2 seconds and remains at that velocity up to 8 seconds. So the body is in uniform velocity because it has not changed its velocity respect to its time. It's constant to respect to its time. So in this graph it represents uniform velocity. What's another? Okay, next graph is straight line sloping upwards. Okay, so in previous graph we have learned that in a straight line, okay, if the line is straight, it is in uniform velocity. But this time the velocity is the line is straight, but it's not horizontal, it's sloping upwards. So what does that mean? So just simply calculate it like this. Okay, these are equal period of time. Yes, so equal interval of time. When jumping from 2 to 4 there is 2, and from jumping 4 to 6 there is 2, from jumping 6 to 8 there is 2. So these are equal intervals of time, and we can see in 2 seconds the velocity of a body is in 5 meter per second. Okay, so that's the base. Okay, so this is the base, the time 2 seconds and velocity 5 meter per second. And in 2 seconds, okay, in 2 seconds, which means in 4 seconds, additional 2 seconds, which means 4 seconds, the velocity goes from 5 to 10. Okay, from 5 to 10, and again in equal interval of time, additional 2 seconds, which means 6 seconds, the velocity goes from 10 to 15, and again in equal interval of additional 2 seconds, in 8 seconds the velocity goes to 20 seconds, which means the velocity is increasing in equally in equal interval of time. So this graph represent uniform acceleration. So this is the definition of uniform acceleration: the increment in the velocity in equal interval of time. So this graph represent uniform acceleration. So what's next? So next graph goes like this. Isn't it the same? No, it is not, because in the previous graph, which is this one, sorry, it's kind of tilt. In this one, the line was tilted upwards, okay, sloped upwards, but in this graph, the line is sloped downwards. So what does that mean? Isn't it same? Yet it's kind of same, but it is not kind of same. What do you mean by that? So let's break it down. Again I am telling you, it's equal interval of time. Okay, 2 additional 2 seconds makes 4, additional 2 seconds makes 6, additional 2 seconds makes 8, and additional 2 seconds makes 10. So it's equal interval of time, and there is equal interval of velocity as well. 5 plus 5 10 plus 5 15 plus 5 20 plus 5 25. So it's equal amount of velocity in equal amount of time. Okay, so in 2 seconds, okay, in 2 seconds our body has the velocity of 25 meter per second. In 4 seconds our body has the velocity of 20 meter per second. In 6 seconds our body has the velocity of 50 meter per second. In 8 seconds our body has the velocity of 10 meter per second. In 10 seconds, our body has the velocity of 5 meter per second. So what does that mean? Okay, I want to ask you a question. Doesn't it mean the velocity is decreasing steadily? Okay, I mean, isn't the velocity is changing equally, or the velocity is decreasing equally in equal interval of time? Yes, it is. And so what do we call negative acceleration? It is decreasing, right? So it should be in negative. So acceleration in negative is known as retardation. So the following graph represent uniform retardation. Okay, now there is one last graph before we end this video. Okay, the last graph is this. What's that? It's a curved line. Okay, so let's break it down. In 2 seconds, the velocity is 5 meter per second. In 4 seconds, by the way, it's 6 meter per second. And in 6 seconds, the velocity is 8 meter per second. In 8 seconds, the velocity is 11 meter per second. And in 10 seconds, the velocity is 25 meter per second. So pause the video and comment down what does this graph represent. Done it? So let me explain. This graph represents non-uniform acceleration. Okay, how? We see the velocity is changing. Yes, the rate of velocity is changing, like from 5 meter to 6 meter to 11 to 25. It is changing, but not at a constant time. But not at a constant rate. Sorry, not at a constant rate. Why? What constant rate? Yes, if it was in constant rate, it should be in straight line, but it is not in constant rate, because first point 5 meter per second, second point 6 meter per second. If it was 7 meter per second in another point, and 8 meter per second in another point, 9 meter per second in another point, it could be constant because there will be +1 velocity in each time. But in this scenario, there is +1, 5 and 6 and 11. Okay, it makes a curve. So when a curved line is represented in the graph, it represents non-uniform acceleration. Velocity is changing, but not at a constant rate. Might be increasing faster or slower. Okay, so for the summary, today we learned about velocity and speed are similar but not the same. One is scalar and the other is vector. Both have same unit, meter per second. Their graph, okay, this is the main point. We have learned 4 graph. Straight line represents uniform velocity. Curved line represents non-uniform acceleration. Upward sloping line represents uniform acceleration, and downward sloping line represents uniform retardation. So if this helped you understand the concept better, don't forget to like, share and subscribe to learn with me in this channel for more fun and clear science and math videos. And let me know in the comments which graph confused you before but now makes sense. Till next time, keep learning with me.